Welcome to the Biochemistry YouTube channel. Year 2016, Part 4, question number 46. Consider the two-state system that are in thermal equilibrium with equal degeneracy, where the excited state is higher in energy level than the ground state by 0.1 electron volt. That is, the energy difference is given. The ratio of population, you have to calculate the ratio of population. Temperature and Boltzmann constant were given. It is 0.05 electron volt. Here the degeneracy is almost equal, where the energy difference E2 minus E1 is given, that is 0.1 electron volt. KBT is 0.05 electron volt, and you have to calculate the population. That is, the population n is given as n equal to G into e power minus E by KBT. This was the population given. Here the two energy states were given. So N2 by N1 is equal to G2 by G1 e power minus E2 minus E1 by KBT. Here you see G2 by G1, that is G1 and G2 are equal, so it is 1 into e power minus 0.01 electron volt, it is given, and KBT 0.05 it is also given, so the final answer is 0.1. Question number 47. Of the vibrational modes given below, the IR active modes are, there was given 3 IR modes of vibration of carbon dioxide, which is, you have to calculate which is IR active and which is IR inactive. Here in carbon dioxide, the first one is a symmetric stretching. And this one is asymmetric stretching. For IR modes of activation, there should not be symmetry, and the change in dipole moment d mu should not equal to 0. Here you see in molecule 1, the dipole moment is equal to 0 because these two dipole are equal, so dipole moment is 0. Here dipole moment is not equal to 0. Here also the dipole moment is not equal to 0. So for point number 2, the selection rule is delta V equal to plus or minus 1, delta J equal to plus or minus 1. For point number 1, delta V equal to 0 and delta J equal to 0. For third compound, for third vibration, delta V equal to plus or minus 1 and delta J equal to 0 comma plus or minus 1. Hence option D is correct. Option that is vibration, second vibration and third vibration is IR active, whereas first one is IR inactive due to symmetry. So option D is correct. Next question, question number 48. A system is described by the following wave function. There is given 3 wave function. This is 1, 2 and 3 wave function. Among this, the probability of finding a particle in the region around the points which obeys the trend. You see, this is 0, L by 3, 2L by 3, where in first one 0 to L, the plot 1 lies in the range, so the probability of finding the particle is 9%. Plot 2 lies in the range of L by 3 minus 2L by 3, the probability of finding the particle is 62%. Whereas plot 3 is greater than 1 but smaller than 2, hence the trend obeys that P2 is greater than P3 than P1. Option B is correct. Here option B is correct. Question number 49. The temperature composition phase diagram has been given for a two-component system X and Y. Temperature 288 Kelvin. The starting point is Py. Y is added until the composition reaches S. Which of the following statement is not true? At point P, the solid and liquid are present in almost equal proportion. At point Q, system is all liquid. At point S, system has more solid than liquid. At R, the liquid is pure X. Observing this graph, at point P, the solid and liquid are present in almost equal proportion. Hence, statement 1 is correct. And at point Q, the system is all in liquid. So it is a center point where all the system are liquid. Hence, option B is also correct. It's also true. At S, the system has more solid than liquid. At this point, yes, the solid is more than liquid. Hence, this option C is also correct. At R, at point R, the liquid is pure X. At R, the liquid is pure X. After analyzing the above graph at R, there is a solid as well as liquid. Both are present. Hence, pure X will not be present. Hence, this is not true. It is not true. Hence, the correct option is D, because they are asking the non-true statement. Question number 50. For a system which is having PV work, entropy is given us. You should know all the Maxwell relation having entropy. Here the entropy equal to dou G by dou T, and here the entropy is dou A by dou T. Is dou A by dou T, dou G by dou T. Hence option 1 and 4 are correct. Question number 51. According to Irving-Williams series, the number of d electron of the first row of the transition metal having highest overall stability constant is in M2 plus ions. The Irving-Williams series, it was the increasing order, the trend of stability constant, barium less than strontium less than calcium. Here you observe this copper Cu2 plus, hence the copper Cu2 plus is more stable than other first row transition metals. Therefore, number of d electrons in the first transition series, Cu2 plus having highest overall stability constant, which is equal to 9. Hence, answer is copper. Question number 52. Magnitude of the difference in crystal field stabilization energy delta naught, that is octahedral, ignoring pairing energy P of Fe2 plus complex and FeCN6 4 minus. Yes. First you take the complex. FeH2O6 2 plus. Here the splitting is given, and crystal field stabilization energy is minus 0.4, and in second complex the splitting, this crystal field stabilization energy is minus 2.4. Hence the difference minus 0.4 minus 2.4, that is minus into minus plus, so it is 2. It is 2.9. 0. Question number 53. The calculated and observed magnetic moment considerably for an aqua complex of lanthanide ions, result of low-lying state of high J. The ion among the following is. The calculated and observed magnetic moment of europium, take europium, was different. Here the measuring magnetic moment and the experimental magnetic moment were different. Hence for europium EU3 plus ion, the calculated magnetic moment is 0, but the observed magnetic moment is 3.4 to 3.6 bm Bohr magneton. Hence europium EU3 plus is the correct answer, because the calculated and observed magnetic moment differs considerably only for europium, other than promethium, cerium and terbium. Question number 54. In electronic spectra of CrF6 3-, absorption band is observed at 670, 440 and 290 respectively due to the transition. For this you should know the graph orbital diagram. Here the transition is A to G to T to G. Here the transition is A to G to T1G. Here the transition is A to G to T1GP. So the answer is option. Question number 55. Among the following group that is bound to the metal ion coenzyme of cobalt, vitamin B12, it is adenosyl compound. This part R is adenosyl 5-deoxyadenosyl compound. Hence the cobalt is bonded to this adenosyl group. C is the correct answer. Thank you for watching. Thank you.